Okay, so thanks, Jim, for the introduction, and hello, everyone. It's refreshing to see people in real life. It's been a while. Anyway, I want to immediately start with the talk. So there's a lot of stuff I want to go through, and the subject of this talk is going to be source code, and this is something that us developers spend a lot of time working with. A lot of our working hours take place inside some code base. And whenever we have to work with this code, whenever we have to change it, we have to understand something about it, because it's just way too big to fit into our brains completely all the time, right? Like we're talking about thousands, tens, hundreds of thousands lines of code. And so, we constantly have to learn something about this code. And even if we're writing a completely new feature, like completely new piece of code, we still have to somehow integrate it with the existing stuff. And so again, we're going to have to learn something about the code. And how do we do that? We read the code and gather some information. And something interesting happens in that process. So intentionally or not, the previous authors on that code we read transmitted some information to us. And transmitting of information is a textbook definition of communication. And so it follows that source code, among other things, is a form of communication between people, not just between the human and the machine. And given how much time we spend working with the code as developers, I would say that it's quite a frequent form of communication between developers on the team. And so it only makes sense to think about how can we make this communication better, more efficient, if you will. And if I could think of one property that I would desire from any communication, then that property would be clarity, right? Which is incidentally the title and the topic of this talk. So we're going to explore the clarity of the source code. And I want to immediately make it a little bit more concrete by showing you some code. So we're going to take a look at some code and try to assess how well it communicates to us, right? The humans. And I'm going to show you one program that solves a simplified version of one challenge from a previous edition of Advent of Code. And I'm not going to tell you what the challenge is, though, right? And so this is quite a realistic situation for me. On multiple occasions in my life, I would find myself in some part of the code where even the purpose was not clear to me. The original author has long departed the team. And, I had to figure it out just by reading the code. And so that's what we're going to try to do by, looking at this code. Don't be afraid. It's like a short program, fits onto one slide, about 20 lines of code. No macros, OTP stuff or something like that. So surely we can handle this, right? And so let's see, we have this function run, which we have to figure out. It takes a single argument called x, and it starts by duplicating number 1 x times, and then it's going to convert this into an integer, and then it's going to produce some elements, right? This is what stream iterate does. The first element is this number we just computed, and then every other element is somehow computed based on the previous one. That's stream iterate in a nutshell. And so how do we compute the next element? We take the previous element, increment it by 1, get the integer digits out of that, and then in that list we prepend number 0 at the very top, and then we chunk every 2 elements in that list, so the first and the second and the third, and so on and so forth. And then we're going to take these pairs as long as the first element of each pair is less than or equal to the second one. Then we're going to take the second element of the pair, and this constitutes our prefix. And now we're going to build our suffix by taking the last element of the prefix, duplicating it n times, where n is the number of digits in the integer, which is the previous element incremented by 1. And then we're going to subtract length of the prefix, and this is the amount of duplications we do of the last element. We get our suffix, then we simply concatenate prefix and the suffix, convert into integer, and this is our next element. And then finally, we're going to take these integers as long as they're less than 10 raised to the power of x, and we're going to count the amount of those integers. So, without saying it out loud, show of hands, who thinks that they understand the purpose of this program and the algorithm that was chosen here, the solution that the author chose. And so, roughly speaking, this is approximately 0 people. So, no surprises there, right? I didn't really give you a fair chance, right? So, it would take some time to figure this out. If I were to see this code for the first time, I would stare at it for a while, then I would sprinkle some debug IO inspect statements, run it with a couple of different inputs, and, probably something can be figured out here. But I mean, this is the problem, right? It now becomes a puzzle, it becomes a challenge, and we have to spend some considerable amount of time and energy to figure it out, And I have to confess that, as the original author, I did a pretty shitty job here of communicating to people, although in my defense, I wasn't even trying, right? So I had this mindset where I was obsessed about solving the problem. I read the problem, I thought about some algorithm how to solve it, and then I just communicated exclusively with the machine. And it took, this kind of mindset, about 30 minutes of my time and about 20 lines of code to produce a hard to work with legacy. So I'm going to show you another program same algorithm, different program, and here the author actually took some effort to communicate to people, not just to the machine. And so we start again with the run function, takes a single argument called length, and it computes or counts the number of valid passwords of the given length, right? And so one line in, we already know the purpose of this program. And this is something you will never be able to figure out from the previous version. Like you can stare at it until the end of time. You're just not going to be able to get it because it's simply not there. The idea of passwords and validity is simply not communicated at all. You know, one line in, we already immediately know it. So what are valid passwords of the given length? We take the lowest or the smallest integer of the given length and the largest one. So for example, if length is 3, that would be 100 and 999. And then we get monotonic integers in the given range. So what are monotonic integers, you may wonder? Like we could Google it, or we could try to figure it out from the code, but the author was considerate enough to summarize that it is an integer where each digit is greater than or equal to the previous one, so 122, 123, but not 121, for example. How do we find these integers? You know, I start just below the lower bound, and I find the next monotonic integer, and the next, and the next, and the next, as long as I don't exceed the upper bound. How do I find the next monotonic integer? So I'm not going to show you that code. You've seen the bulk of it in the first implementation. This is where most of the complexity lies. But again, the author was considerate enough to summarize this for us in, you know, too long didn't read short steps in plain English, and most notably to note that this is a constant time algorithm. So somehow it's able to magically jump in a single step to the next monotonic integer, no matter how far away it is from the given input, right? So not a brute force scan. And this would roughly be a small demonstration of what I consider to be clear communication to people, right? And I have to say that, like, more recently, I'm preferring to use the term clarity in favor of these other terms. I mean, these are definitely properties that we want from our code, but the problem is that they're like very, very vague, very hard to define, even remotely precisely. And so what happens is, you know, they're open to subjective and creative interpretations. And I have witnessed a bunch of discussions where one developer claims that, like, this code is readable or maintainable, and another one claims it is not, and now we reach an impasse, and like, where do we go from here? Typically, it leads to very unproductive, long, futile, energy-draining discussions, you know. And while clarity is not something we can measure scientifically, I hope at least that it is a little bit more concrete and that it makes it easier for us to find some common ground. Because what we're looking for here is like that as a reader who is reasonably fluent with the language of communication, I want to be able to reasonably, effortlessly understand the purpose of the program, like what is even the problem this thing is solving, and then the solution that the author chose, right? And out of this I get knowledge, and with this knowledge I'm empowered to work further with the code, you know, to make some changes, to take it further, to fix problems, to optimize it, even to rewrite it. So for example, let's say that I found myself in this piece of code because there were some performance issues. So, you know, circumstances have changed. Previously, I had to support, or we had to support, like fairly short passwords, only a couple of digits, but now we have to work with like much longer password, 100 digits or more. And, you know, now the program is unacceptably slow, and so now that I actually understand how the author solved the problem, I can figure out, okay, this algorithmic complexity is actually not sufficient enough for our scenarios anymore, and so I have to think of a faster algorithm. And so the original algorithm was not fast enough, and I had to think of a faster one, and this was the fastest one I was able to come up with. I'm not going to have the time to explain it, but essentially it's a linear complexity algorithm, meaning that, for example, to count the number of 100-digit monotonic integers, it requires only 100 steps, where the previous version would require about 350 billion steps, you know. So blazing fast, pretty short. I don't think that it is clear, and I don't think that I can clarify this through code alone, you know. I think that I would need like a large block of prose, of comments, you know, with some step-by-step example illustrations and whatnot. But anyway, you know, this is a full rewrite of the code, but the very reason I was able to choose to make this decision, right, and to make this rewrite is because I was able to understand the original program together with its shortcomings, right? And so this is what clarity means to me, and more generally the benefits would be it makes us more efficient and effective, which means that we can gather information faster. We simply spend less time, you know, trying to understand something because it's better communicated, and we get better knowledge. The information is transmitted with higher fidelity, if you will, which means that we are less likely to you know, miss some very important but implicit, non-obvious relationships and dependencies, and therefore we are less likely to introduce unexpected bugs or performance regressions. And so, again, essentially, you know, we're faster and better. Surely that's a good thing, right? And on top of that, clarity empowers the team. reviewing, right? And so we move away from this mindset where like only the original author is qualified enough to work with the code they wrote, to the point where everyone on the team is confident enough to work with any part of the code. And so this assists with team dynamics. So this is something happening quite frequently in our industry. You know, people are coming and going. You know, people may move to a different project. They may switch to a different role, like say manager role, or people may move to a different company. And so if the code is clarified enough, then the negative consequences of people departing the team are significantly reduced. And the onboarding overhead of new people arriving to the team is also reduced, again, because everything is, you know, communicated much more clearly. And so to me, these are like benefits that I would want from any sort of a project which is developed as a team effort over some longer period of time, which I think describes any like real-world project, be it commercial or open source. And therefore, to me, clarity is an essential property, you know, something that I want to have inside the code base, and I would give a very high priority to it, you know. And so this begs the question, like, how do we get this thing? So we have to, you know, we're not going to stumble upon it by chance. You know, we have to make some effort to make it happen, and we have to invest some effort constantly, right? So, like, forget about the idea that you're going to ship features for a while, and then you're going to spend like every X months, a couple of weeks clarifying your code. Like, that's not going to happen. You're paying lip service to clarity, nothing more than that. You know, you're going to end up with the same old, you know, obfuscated, convoluted legacy mess of the code no one ever really wants to work with, right? So, if you really want clarity, you have to invest some part of your effort continuously. And the key practice here, in my opinion, would be the practice of code reviews. So the first and foremost, you know, the primary focus of the review process should be on clarity, right? Because everything else comes out of clarity. Like, how am I even supposed to, you know, spot some problems, issues, deficiencies, missing parts of the implementation, missing tests and whatnot, if I cannot even understand the code, right? That's not going to happen, and the practice basically loses its purpose. So, you know, clarity is the primary focus. Out of that, it follows, in my opinion, that pairing is not really a proper substitute for reviewing, because pairing, as the title says, is programming, and therefore, you know, both members of the pair are programmers, right? And so what this means is that, like, they both participate in the programming session, in the journey. And programming session, you know, is not just the act of mindless typing. It is you know, the act of exploring, right? So you immerse into the problem, and you try out different approaches, different venues, and by the end of that session, you develop a very deep, intimate knowledge with the solution and with the problem as well, right? And so this is everything is naturally clear to the author, you know. And so this is the luxury that no other reader possesses, including the future version of the author. And therefore, you know, to review, you need a fresh pair of eyes. And so basically self-review is not going to be sufficient enough, and pairing to me is a form of self-review, you know, the pair programs and reviews together. So we need, you know, someone who did not participate in this journey to actually assess the outcome of, the final outcome of that process for clarity. The process of review is going to introduce some tension in the overall development process, right? So the thing is that we want to merge as, you know, reasonably fast. Because merging means progress, right? And progress is what we're after, because without it, we're out of business. But at the same time, we want to clarify as much as required. And we're going to postpone our merge to do this, right? Because clarity also means progress. It means subsequent progress, right? It's not like we're building the current set of features and we're done with it forever. You know, we're actually going to have quite a long road ahead of us, and we don't want to compromise our journey or our ability to progress down that road, right? This is why we want clarity, you know? And so how do we resolve this apparent tension? Essentially, in my opinion, the author and reviewer should work a little bit more closely with each other, help each other to make this process effortless, right? And so let's start with the author. So beyond just implementing the feature, an important task of the author is to make the job of the reviewer as easy as possible, because this leads to fast review, fast feedback, and good quality feedback, right? So the reviewer is more likely to spot some problems. So first and foremost, try to make your pull requests reasonably small, right? Because this is going to be like the theme of this entire talk. You know, us humans are pretty terrible at dealing with a large amount of information thrown at us at once, at the same time. And so instead, you know, what we need is for this information to be presented to us more gradually, more incrementally, in some reasonably sized chunks, which we can understand or study in isolation, right? And so talking about pull requests, you know, frequent misconception that I've noticed is like people conflate it with feature, right? The whole feature doesn't have to be implemented as a single pull request. If the implementation requires a large amount of changes, then split it somehow into reasonably sized smaller pull requests. The same thing holds for commits. Like if you give me one commit which packs 10 different types of changes together with a couple of refactorings and optimizations thrown for good measure, I'm not really going to be able to figure it out. Or even if I'm able to understand something, by the time it happens, I'm mentally wasted and I have nothing useful to give you. So present it in smaller steps, and most notably, try to make your history linear, right? So the thing is, again, programming is a journey, right? And it's not necessarily a straightforward journey from point A to point B. It can be quite long-winded as you're trying out different venues and approaches. And try to hide away the details of the journey from the reviewer as much as possible, because it's mostly useless to them and it's mentally very taxing for them, right? So clean up your history as you move along. Clean up your history before you submit the pull request, and then occasionally, on very few occasions, but it happened to me, like the history was beyond the point of repair, and then what I would do is I would recreate the change in a more linear fashion, right? So now at this point I actually have the working version that I want to submit, and I'm just going to linearize the history by recreating it again, and I'm doing this not to make myself look perfect, but to make the job of the reviewer easier, because again it leads to faster feedback and more quality feedback. By all means, do self-review. As I mentioned, it's not going to be enough, but you can self-review and clarify as much as possible, and this may help the reviewer tremendously. Now, this attitude cuts both ways. So, as a reviewer, be mindful of the fact that everything is super clear to the author, and so your first task is to actually point out places where you had problems understanding. Like don't be shy to say, like, I had problems understanding this part of the code. I wasn't able to understand this function at all. You're not the problem there. Even the author is not the problem. The code is the problem, and this is what we want to fix, right? But going beyond that, you actually have a better position now, because again, everything is clear to the author, and so you are, I would say, more likely to make some better suggestions about how to improve it. So don't be shy to make some suggestions as code snippets. And what I occasionally do, like when I'm not completely sure what's the best way to go around, as a reviewer, I'm going to do a refactoring session on my own and explore it. So check out the branch, do a refactoring session. If I'm happy with the outcome, I'm going to submit a pull request on top of pull request. And so the roles reverse for that brief moment or period in time. And then one thing that I feel that many of us are not doing frequently enough, definitely not me, synchronize, right? So not everything has to be done asynchronously through pull request comments. Sometimes it's more efficient to reach out directly to the author and try to discuss problems and various ideas. So through chat or voice, pair by all means. Pairing is most certainly a wonderful technique that can complement the review process, but in my opinion, not replace it. So anyway, this is what I like to call collectively collaborative review process, and I feel that many teams are perhaps not practicing that style, so give it a go and see how it goes. I think you might get pleasantly surprised. Either way, let's turn our attention to the code, right? So how can we make our code clear? What is this secret sauce? And I would say that we could easily spend this entire conference, discussing various patterns, techniques, approaches, architectures, and whatnot. But I think that there's like this very small, simple idea, which when properly followed, naturally leads to many good properties, such as good modularization with high cohesion, low coupling, good, well-intentioned revealing names, and by following this idea, we naturally can arrive to design patterns and architectures which are good fit for our particular scenarios. And this idea, which I'm going to discuss next, is called separation of concerns. So separation of concerns is a phrase attributed to Edgar Dijkstra. It appeared originally in his 1974 essay called On the Role of Scientific Thought. And this essay is not about source code at all. It deals with some higher level programming topics, but definitely not source code. And it's essentially, an essay about the style of thinking. And so the way I would summarize it, the way I see it, is what Dijkstra tries to say is like when he is studying some subject, some material, he wants to be able to look at it from different points of view, from different aspects, in isolation from all the other aspects, right? And so nothing particularly groundbreaking here. This stuff has probably been known to us like since ancient times. It's a basic breakdown of a problem, or divide and conquer of some sort, if you will. Even Dijkstra admits as much, at the very beginning of the essay. But the thing is, this is described, this whole essay is written from the standpoint of a student, not like a college student, but from the standpoint of a person studying some material. And assuming we agree with this approach, which I most certainly do, then as writers, in this case as writers of code, what we want to do is we want to split the code into parts which can be understood in isolation. Again, nothing particularly groundbreaking, not so big idea really, but I feel that we very frequently lose the sight of this idea, you know. So most notably, not every partition of the code actually fulfills that goal, right? So if I have somehow like a program, big program, and I split it into two parts, which I always have to understand together fully, then I haven't, you know, reached that goal. And in fact, I have made things worse, you know, because every split also adds some mental overhead, or if you will, you know, abstraction is not a zero-cost abstraction, right? So, you know, we have to actually reach that goal. So let's see some concrete examples. Suppose we have to implement the following system, a very small system, you know, we only have to support 2 use cases. So a user can register with an email and a password, and the registered user can log in with the correct email-password combo. And this, let's call it ambitiously, requirements document already practices itself separation of concerns, because it does not deal with, you know, a bunch of other things such as user interface, the fonts, the colors, accessibility, mobile versus desktop. It does not deal with networking protocols, delivery guarantees, and so on and so forth. All important things that we need to solve in order to build a full product. But we just cannot handle all of this at once. You know, we're just going to crumble under that mental load and do nothing useful, right? And so here, you know, we are focused first and foremost on the core behavior of the system, the very reason why we're building the system in the first place. And so to mirror that in the code, you know, I would separate the code into these 2 regions. This is what I would start with. So I would have the core layer, which implements the core behavior, and on top of this, I'm going to stack the interface layer, which exposes the core to the external users and clients, you know, such as browser, REST client, GraphQL client, Phoenix channels, live view, and so on and so forth, you know, whatever delivery mechanism you want to use. And I'm not doing this because I read it in some book or because some thought leader said so, but I'm doing it because these are 2 very large parts that can be separated from each other and understood in isolation from each other. You know, you can most certainly work and understand the interface without caring about the internals, the ins and outs of the core implementation, and vice versa, right? So this is the general idea. So okay, let's see some code. So far I have been using the Phoenix namespace convention, so for me core would typically reside in my system and interface in my system web. More recently I'm toying with the idea only in my mind to go for mysystem.core and mysystem.web.interface because it maps precisely to the way I regard this code, but I haven't tried it out, you know, so this was just a small digression. Doesn't really matter here because this is the last dev module that we're going to see today. So anyway, top level core module has the register and login functions corresponding to our 2 use cases. Signature-wise, don't be bureaucratical about it, you know, whatever works. So, like, you can accept individual parameters if you're dealing with 2 or 3 parameters. Obviously, if you deal with like a larger amount, you're going to accept them somehow. You want to bundle them somehow rather than have a function that takes 20 parameters. And so let's focus on this case, right? So we accept params in the core as a map. Let's see type specification. So the main thing to notice here is that the data coming into the core is well-shaped, well-structured. So this means that keys are atoms, and we are dealing with a well-defined set of keys, right? So it's not a free-form map. Values are properly typed, strings are strings, integers are integers, booleans are booleans, and so on and so forth. And then we have optionality represented as well, so email and password are required, date of birth is optional. And this to me is a small demonstration of what I personally consider to be the most important benefit of types, and this is clarity. Types clarify. They describe more precisely the nature of the data coming into the function and out of it. And I find in practice, like with a good chosen name and good type specification, I can frequently build a very good intuition about the function without having to fully read the documentation or, God forbid, the implementation, right? So that will be the main benefit of types for me. So anyway, you know, here from the type specification, we can actually see as potential clients how to use this code, how we can pass something, what should we pass into this function. And so let's see one client. So this will be Phoenix controller, the standard action handler. So we take con and params here is a free-form map, which means that keys are strings, some required keys might be missing, some keys we don't support might be present, values could be weakly typed, right? So if you're dealing with query params of the URL, then all the values will be strings. We have to deal with all this uncertainty someplace, and it's pushed outside of the core, which keeps the core more focused. To be clear, it does not reduce the amounts of lines of code in the core, but it just keeps the core clearer. There's less uncertainty there, right? We're dealing with this in the interface. And so we have to give the structure to this, and this is what I like to call normalization, to distinguish it from validation, right? So validation to me is about, you know, enforcing business rules and constraints. Normalizing means just giving structure to unstructured data. And how do I do this? I define a schema where I describe the fields I expect and the types and optionality, and then I invoke a helper private function called normalize, which unfortunately I don't have the time to show you. But this normalize is going to normalize params according to the given schema, and basically it's based on schema-less ecto change sets, right? It's a generic piece of code, not particularly long. If I advise to try it out. It's a nice little practice, even if you're not going to follow this style of programming, just give it a try. So anyway, we normalize and we get the structured params which we can now pass to the core, and then we render success or an error. So to me, this is a more refined idea that follows Phoenix context. It goes in the same direction, only goes somewhat further. And I want to contrast the two approaches because I think there are some interesting points to be made here. So as a refresher, in Phoenix context, this is how the controller would look like. You take these params and pass them immediately onto the context function as they are, right? So way less lines of code here. The context function is not going to be any larger because of that. So in general, less lines of code. We can build our features faster. We are more productive, and these are very nice benefits. But these benefits have been obtained at the expense of clarity, and this is something that I have observed, through experience a lot of times. It's not a rule, but frequently various abstractions and ideas that promise productivity and reduce lines of code do so at the expense of clarity. And so if you care about clarity, do assess them from that point of view. Right, so let me try to prove this. So this is the type specification of the context function, and immediately from this specification we see that this uncertainty has been now pushed deeper. Right, and so as a potential client, if I want to use this context function, what should I pass inside? No idea. I have to read the full implementation of that function, including every single other function it invokes, such as the change set function from the schema module. And so in order to understand anything, I need to understand everything. And the role of modularization, of separation, has not been met. And so this to me is probably way less clear, way more obfuscated. But it does not mean it is bad. I actually completely agree with the Phoenix idea, right? And so we got to get out of this absolutistic mindset where things are universally good or universally bad, So we have to keep in mind that Phoenix onboarding documentation and generators are all about the onboarding experience, right? So bringing a person who doesn't know anything about Phoenix to the point where they can work with Phoenix, do something with Phoenix, right? And so it only makes sense, to make these more lightweight choices, if you will, because imagine if like the onboarding material taught Phoenix together with DDD, event sourcing, CQRS, hexagonal architecture, microservices, like who would be able to understand anything out of that? And in a sense, this is a good example of separation of concerns. The onboarding documentation, the onboarding material concerns itself with the onboarding, right? As it should, But then it's up to us, the recipients of information, to understand that, like, okay, one thing is to, build something with Phoenix. There is another thing to produce the code which can be further maintained by the team, not just by the original author, right? And so if we just blindly copy-paste stuff from the documentation without, critically thinking it, then we are effectively cargo culting, So try to be always a little bit more critical about any ideas you're presented with. So anyway, let's go a little bit deeper. So the implementation of the core function, one possible implementation, again, follows the blessed way, so to speak, as proposed by documentation/generators. So we instantiate a user struct, which would be an ecto schema, then invoke a change set function, and then we insert this into the database. So this is one of the very few places where I strongly disagree with decisions made in Phoenix. So let me try to argument this. Basically, if I were to translate this into more plain English, it would read something like: prepare user for insertion for the purpose of registration, then insert. Right? And so this is a very long, convoluted way of saying insert user, right? This prepare blah, blah, blah means nothing to me, It's just noise. It's not something I can relate to. It actually leaves more questions than it answers. It answers 0 questions to me, And so again, what I find in practice, I always have to read this code 100% of the time together with the change set function, and vice versa. I can never really fully understand that function in isolation. So again, the goal of separation has not been met, It's a split of some sort, but not a separation of concerns in my mind. And so what I would do and what I would suggest starting with is, I would just stash this stuff together directly in the core code, There's not a lot of code here. It's best understood really if it's put together. And we have no other architectural constraints, forcing us to split it. So this is what I would start with, and then I would, split it when I have some reasons, when the code grows. So for example, let's say that we have to send an activation email on successful insertion, then I might end up with something like this. And now these lower level concerns are naturally emerging, driven by the actual requirements. And the big point I want to make here is that like concerns are best chosen by looking at the actual material we're dealing with, not by waving our hands through the air randomly and citing various random principles. You know, that's going to be very counterproductive, in fact. And so another example of this line of thinking, so going back to the architecture level, we have two layers currently, interface and core. And I'm calling it core because it's not pure business/domain, right? So we're dealing with some business/domain things, such as, you know, use cases, flows, business domain or domain level rules and constraints. And then we deal with infrastructure as well, which means that we have to interact with services that we're using ourselves, right, to provide our own service. So, for example, database most frequently, mailer service, notification service, payment gateway, Infinidash, you know, whatever you decide to use. And so surely now this looks like these are definitely two concerns which we should split, you know, but it really, again, depends. Because the thing is that splitting business from the infrastructure is going to lead to more ceremony. You know, the similar, I would say actually the larger amount than the amount we already introduced in the initial split. And so this is your overhead, right? You're going to go for like either 3-layered architecture or dependency injection-based architectures like ports and adapters, aka hexagonal, or clean architecture or onion, you know, whatever. And this is going to add some amount of complication in the code. And so it's got to be worth it, right? So like in our current system, you know, obviously the code is way too small, but the really important thing is that the business logic is really thin. No particular complexity there, right? And so if we split that kind of code, you know, essentially the most complicated part to understand about our code is going to be the architecture itself, which kind of defeats its purpose, you know. So more generally, I would say that like for, let's call them agency-style projects, you know, where a bulk of your core is dominated by infra and you have relatively thin, you know, business behavior, I think that this is a perfectly fine approach, and this is what I would go for, and this is what I would start with, right? But obviously, you know, if you're like working on more enterprisey domains, I don't know, you're dealing with insurance policies, loans, mortgages, and whatnot. You know, you have more complexity there. Then, of course, the split might be worth it. So again, you know, consider the actual situation you're dealing with. You know, don't just do something because some thought leader or authority said so. You know, even if that person is me. You know, so just think contextually. You know, think inside of your situation. So anyway, the last thing I want to talk about are tests, right? And so this is one place where I think that the battle for clarity is frequently and very rapidly lost. And so I want to start by talking about the purpose of tests. You know, why are we even writing them in the first place? And it feels really strange that I have to say this, but you know, here goes. In my strong opinion, tests should be used to test, right? And if you're considering, or if you're using them for something else, do consider giving them a different name. And I mean this in the nicest, you know, most constructive way possible, because different name clarifies a different purpose, and different purpose means different choices, right? And so here I'm going to focus on test for the purpose of testing. And what does that even mean? You know, system, we're testing the system, and system is all about the behavior, right? And so what you want to do is test behavior, not implementation details. This is one of my favorite programming quotes by one of my favorite technical talks by Ian Cooper, TDD, Where Did It All Go Wrong? Highly recommended. And then in the same fashion as a more in-depth exploration, I also recommend this book by Vladimir Korikov, Unit Testing, Principles, Practices, and Patterns. Very good read, right? And so what does that even mean to test the behavior? So roughly speaking, you want to focus less on lower level abstractions and more on like things which are actually, which make some sense, which are concrete and tangible for external clients of your system or external users of the program, right? And so use cases would be a prime example here. For example, testing the behavior of registration, testing the behavior of login, and so on and so forth, you know, because collectively use cases fully describe the behavior of the system. Now, making exceptions when you have good reasons is perfectly fine, you know. So like if I had some complex abstraction deep inside some layer, I may decide to test it directly, for example, for performance reasons, right? Because the test is going to run faster, and also usually or frequently it may be, you know, simpler to write the test which tests the abstraction directly rather than going through a bunch of layers, you know. And I might also be able, it may be possible for me to trigger some execution path which is otherwise impossible to trigger. So if you have like good reasons, definitely do so. But like as a guideline, not as a rule, as a style of thinking, my first consideration is always to test as much as possible through use cases, right? Because this is how I'm focusing on behavior. Do not feel compelled to test each module or class in OO directly, right? So Vladimir describes this nicely in the book, The unit we're testing, the unit that we're looking for is the unit of behavior, not the unit of code, right? And so it doesn't really matter if that unit of behavior is powered by a single module or by multiple modules, that's the implementation detail, right? So for example, Phoenix View to me is always an implementation detail of the controller, and I rarely test it, if ever, directly. Thinking about it, I don't even test the controller directly. So what I do instead is I build a con, right? I'm using the Phoenix test support, build a con, and go through the full pipeline. So it exercises, that single test exercises the endpoint, various custom plugs, the router, the controller, the view, and to me it is still not an integration test. It's a test of a behavior of the public API, right? So this is the way I see it. Highly related, do not feel compelled to obsessively mock or stub away dependencies of the thing you're testing, right? So Ian and Vladimir describe it that like in the classical school of TDD, when we talk about isolation, the thing that has to be isolated or the thing that we want to be isolated most of the time is a test itself, not the thing being tested. Test is isolated if its execution does not affect the outcome of other tests in the suite, right? And so this is what you're striving for. You do not have to isolate the thing you're testing, right? That being said, of course, if you do have good reasons, again, use test doubles. So for example, mocking away non-deterministic stuff like remote network dependencies or time, perfectly fine. Mocking away global shared state, also a good example. This is, by the way, how you isolate the test, because multiple tests, depending on the global shared state, may affect each other's outcome, right? Mocking because you will get some significant performance gain, also perfectly fine, But don't feel compelled to mock everything away, right? This is a very, I would say, overly simplistic view and perhaps even a wrong view of what has to be isolated. Try to avoid directly depending on internals, right? On internal structures, such as socket assigns inside channel tests or live view tests or database structure inside most tests. This is a very frequent example. These are things which are very prone to change. So like I change the database structure, adapt the implementation, my code is working, my program is working correctly, and I have 100 tests failing, which I have to fix frequently one by one, right? This is very, very depressing and demoralizing. And more generally, I would say that in my sentiment feeling, tests, the more the tests are coupled to the implementation level details, the more prone they are to both false positives and false negatives, meaning they are more likely to fail even though the program is correct. But what's even worse is they are more likely to pass even though the program is wrong, right? And this reduces my confidence in tests. And confidence is the most important property I want from my tests. It's like the very reason why I'm writing them in the first place, right? And focusing on behavior increases our confidence that system is working as expected. Yes, tests cannot prove the absence of bugs, so I'm not going to get 100% confidence, but like most other properties in life, confidence is non-binary, right? Including clarity. Clarity is also non-binary. So you can have more of it, and you can have less of it, and in this case, more is better. Focusing on behavior increases that confidence. This style of testing also improves clarity of the code, first and foremost because we're going to use significantly less test doubles, and these things complicate the code, the production code and the test code. But more importantly, tests which focus on behavior play very nicely, go hand in hand together with the practice of refactoring, because refactoring by definition means changing the internals without changing the behavior. And so if you've done everything right in a refactoring session, your tests are passing. If you've done something wrong, some tests will fail, which is precisely what you want. And of course, refactoring is a very important practice, which allows us to keep our code in sync or clear enough with respect to the ever-changing world, as driven by the constant stream of requirements coming our way. Test code is code. So of course, it is code. Test code is code which is maintained and managed by the team, right? And so it should be held to the same level of standards with respect to clarity as the production code. And I would say that we even maybe want to go like 1 or 2 steps further, because it's annoying enough when a single or some tests are failing. It becomes downright depressing when we have to spend some considerable amount of time trying to even figure out the purpose of the test. And like, is this even a bug in the program, or should I fix the test? So try to avoid that, clarify your test as much as possible. So a couple of short examples. So here I'm testing the behavior of the public API, registration operation, happy path. So I build a valid input, and then I use Phoenix S support to build a con, make a request, get the response, decode it, and assert something about it. 4 lines of code, pretty short and sweet, I would say. If you're familiar with Phoenix and testing, it should probably be good enough for you, but there is already some amount of mechanical noise here, and this is going to add up the more tests I write, and the more I have to deal with like a larger amount of parameters. And so what I want to do is I want to aggressively push this stuff deeper away from the test, and I'm going to end up with something like this. So I'm going to introduce this register helper. It starts its life as a private helper function in the test case module, and then eventually it might make its way to be a part of some public API of a test support module. And so this register function deals with all the mechanics, right? So it builds a con, issues a request, decodes the response, and as an added bonus, it's also going to atomize the keys. Something I can safely do here because I'm in the test code, and this reduces the noise from the test. And so with that helper in place, I end up with like this piece of code which communicates exactly that which is relevant for the purpose of this test. Nothing more, nothing less. And this to me means clarity. Another example, so testing that user cannot register with an email of an already registered user. So we need a registered user in the database first, and I'm going to create this user by going through the API. Public API is fine, core API is fine. Try to avoid as much as possible inserting directly into database, because again, this will couple you to implementation details. And what's even worse is you're going to end up inserting data which is actually invalid according to various business rules. And once that starts failing, which it will, I wish you a lot of luck because you're going to need it, right? So try to avoid it as much as possible. So here I'm going through the public API simply because it's more convenient. I just built a helper function for that. Although here I had to build another small wrapper around it, so register with a bank, which raises if the operation doesn't succeed. So this is my precondition here. I'm not testing this first registration, right? I'm assuming that it's going to work. Most notably, do note that I'm only passing the email parameter, right? And so I typically build these helpers to provide default valid values using uniqueness where required, and this allows me to remove a huge amount of noise from these tests. Like here it's not so dramatical because we're dealing with just 2 parameters, but more realistically we're going to deal with like 5, 10, 20 parameters. And if I had to specify all of those here in this test, it's a lot of noise, distracting noise. It's very hard to figure out like what is actually relevant for this test, and email is the only thing that we care about in this particular test. And so with all that in place, we end up with a nice BDD like given when then test. So given a user registered with some email, when another user tries to register with that same email, then the operation will fail with the following error. And in the same fashion, testing the login operation. So given a user registered with some email password combo, when the user tries to log in with the same email password combo, then the operation will succeed. And this is an example of how I'm decoupling myself from implementation details. So this test exercises the storage mechanism, the database, right? So register is going to store something into the database, and the login is going to read something from that database. But I don't care about it in the test. So this test exercises the system using the core vocabulary, the abstract core vocabulary. A registered user can log in. Not like if I insert a user record in this particular shape and invoke the login function with those parameters, then this will be successful. Like, what does that even mean? It's way more confusing to me, and actually gives me sparks less confidence, if you will, right? So in summary, source code is a frequent form of communication between team members, and if you want to make that communication more efficient, clarity is the property you're looking for. Dedicate to clarity, focus on clarity. This is what you're after, not satisfying some random set of principles or winning the architectural award of the year. All interesting goals probably, but that's not what we're after. We're after clarity because it means progress, right? Practice code reviews focused on clarity, and collaborate in those code reviews. Help each other, work with each other to make this process efficient and effortless as possible. Organize your code into pieces which can be understood in isolation from the rest. This is the separation of concerns done right. Not every split of the code is separation of concerns, no matter how people are trying to frame it or spin it, right? Test behavior, not implementation level details. And then as a sort of underlying theme of this entire talk, clarity is not something you can reach by just following some set of rules mechanically. It's a more creative process, not in the artistic sense, but in the sense that like you have to consider the actual situation you're dealing with. And so try to avoid any absolutistic dogmatic reasoning, think more contextually, think more critically, and I think that you should be fine. Thank you very much.
All right. Thank you very much. We have some Q&A. Okay, mic's not working. And so let's see here. It may be easiest if folks who want to ask questions here come up and queue up here to ask questions. And while you're doing that, I have some online questions. So Barbara, help me out here. We've got the first question, and that's Sergey is online. I think if you unmute, you can ask your question and we can all hear it. Nope. Okay. So it's not going to work. We tried it and it worked, but I'll read Sergey's question. On what level should Clarity be implemented? Variable names, function names, or function doc blocks?
What was the last one, the function?
It says doc blocks. Function, I think he means function blocks.
Function blocks. Well, I mean, it should be ideally implemented on all levels, right? But of course, obviously, we're going to gain more at the higher levels of abstraction. So this is what I would focus on first, So like separating interface and the core, for example, already brings us a lot of useful stuff. And when we're talking about low-level implementation, you definitely want to have good names. A frequent misconception, which I also did myself, is that we necessarily have to split things into functions. This can actually also add some problems because we have to jump back and forth. So adding a good meaning variable name instead of extracting something to function can actually also help a lot. And so I don't know if that actually answers the question, but
no, I don't know. Appreciate that answer, though. You want to try again, or do we want to? Yeah, try again. Next question. Okay, so let's do the next question, and that's by D. Hutch. So if you're online and you should be able to unmute and ask your question. All right, I'll ask it. If unit tests are to be considered as units of behavior, does this not imply that only happy path explicit use case functionality should be tested?
Does this imply that only happy path use case functionalities should be tested? Well, I would say no, so it depends on what a happy path is, So for example, to me, let's talk about registration. Like if I provide an email of an already registered user, so this is obviously rejected. To me, this is actually a happy path in the sense that the program successfully rejected a business error, right? And so this is definitely something that is part of the behavior and probably should be written inside the use case as well. And so this is what I would test. If there is an exception, because we have a bug or maybe some input is provided which we don't even support, then this is not a part of the behavior and this is not something that you should want to test explicitly. You may want to if it gives you more peace of mind, but I most certainly wouldn't. Or as a guideline, I wouldn't really go for testing stuff which I don't even support, which are not a part of the use case. But business kind of errors or any other sort of errors that we actually plan for and somehow write them up in our use cases are certainly things that are part of the things we should test. Yeah.
All right, thank you very much. Okay, next question. This one's got 14 thumbs up. Let's say you dive into a code base not following most of the tips you shared here. What should be some of the first changes you'd suggest that you feel bring the best bang for the buck for unclear code bases? Yeah, no one's ever dealt with unclear code bases, right?
This one can be, I can see why it has so many thumbs up, right? Probably many people can relate with this. Well, I guess that I would first start with, defining some practices around, something I actually wanted to talk about, but obviously I already crammed too much stuff in this talk. So you want to set up practices of code review and practices of, for example, automated checks for all the low-level stuff like formatting or style guide enforcing through linter. In this case, it would be Credo, right? And so those kind of things would be the first thing. This is not going to fix the problem at all, but it's at least going to remove some mechanical noise, and it's like a low-hanging fruit which we can do. Other than that, we would have to establish some sort of like the way we want to go forward. What are we striving for, and then gradually try to move this thing away to that. What I definitely do not recommend as the first consideration is a big rewrite, right? So people usually, think that this is the easiest way, but ultimately, on many occasions, I have heard, stories that they end up with just how is it called, the second system effect, right? Or where they basically, repeat the mistakes of the first or make some different but same kind of mistakes as the first version, right? So try to do it incrementally through practice of refactoring. When you're adding new code, try to follow these new ideas that you want to enforce, and then gradually you should be able to at least, to some extent, clarify it.
All right, thank you. We've got another question here. What strategies do you suggest to minimize the complexity of split testing your behavior? How would you go about testing this behavior?
Of split testing? Hang
So
on a second.
what strategies would you suggest to minimize the complexity of split testing your behavior?
Of split testing the behavior. I don't know what that means. Does anyone have a clue here? Like? Like A/B testing. Oh, wow. That's something that I would have to consider before answering or think about it for a while. Yeah. So this one is really interesting. At some point when you do have like two things, right? Two different versions you're supporting, both are part of the behavior. So definitely I would say that you want to test one and another, right? As well. So how is this done operationally? I must confess that I never did it, so it can be a little bit tricky, but you can most certainly do it, right? And this is what you want to strive for, because it is, after all, the part of the behavior that for some people it works like this and for others like that, right?
Okay, thank you. Are there any questions here from the live audience? Yeah, why don't you come up here and we'll ask the questions. So you can stand here and I'll hold the mic so you don't have to touch it. So.
Saša, thank you for the talk. Question about talking about Git and linear history. What other histories do we have?
I'm sorry, what other histories?
Do we have in Git?
What other histories do we?
Do we have in Git? We have linear. You said linear history.
Yes.
It's opposite of linear history.
Oh, the opposite of linear history is like if I try I'm solving some problem. Let's say that it's a more complex problem. So not like, adding a new field to the form or something, more involved. So, I move along further a little bit, and then I figure out, oh, this is actually not right. And so I'm going to try to move somewhere like horizontally more, and then, I'm going to try it there. And then I figure out, oh, actually the first idea was good. So I'm not going to return there, but I'm going to just, continue on the journey along the way. And it like goes, or in a long-winded way, sort of. Yeah, what I try to do as much as possible, as I move along, when I'm making some change, I try to think like, can I actually amend the history immediately so that it's always as linear as possible, rather than, but some problems are more difficult, and you ultimately cannot focus on all of that at the same time, and then, I'm just gonna do a bunch of, commits which make complete nonsense, not even to me, let alone to anyone else, and then what I'm gonna do is either try to, somehow squash some of those commits, or when this is not possible, then I'm just going to recreate this change again, But I'm not going to like type it again. I have the working version of the final solution, and then I'm just going to, try to reapply it more incrementally in a branch, more linearly, if you will. Does that make sense? And adding to this point, I'm a strong proponent then of explicit merge commits, because it really keeps, the documentation, like these fine-grained commits actually explain better the way the thing was implemented, while the single pull requests explains why we had this feature, like the bigger context,
Next question. Next question. I'll hold the mic.
Okay. Cool. Hi, Sasha. Thanks for the talk. It clarified a lot, pun intended. So I wanted to say something and ask something. First thing is about the split between the interface and the core that you presented. I think that's a very valid idea. We saw that work pretty well when we actually started to add a second interface. So we've actually started to add like a gRPC interface to some of our services, and some of the logic underneath had to be the same or similar for the HTTP calls and the gRPC. gRPC is highly typed, so it was good to kind of set the types above the core. So that worked well for us. What I wanted to ask is, and you mentioned like these cases where somebody sends you a huge like pull request, and I'm sure like everybody can relate. Like at some point in their life, they got like 2,000 lines of code to review, and I'm probably guilty of creating some of those myself. So my question is like, do you have a thought experiment or a mental model that somebody can follow to actually split these pull requests into smaller pieces? Because sometimes I got the feedback from the person that created the pull request that they just kept adding and they didn't know where the boundaries are. So do you have anything to like a thought experiment?
Well, other than some gut feeling, I don't really. I just when I program myself, sometimes you can decide up front, like, okay, this is clearly going to be like a huge change, and so let's try to organize it into some smaller pieces. But it actually more frequently happens to me that I'm just coding, and at some point, like, okay, this is getting out of hand, and this is the point where I'm just gonna try to stop and see what could I wrap up, which actually makes sense at this point, and submit for review. And in that pull request, I'm gonna say, okay, this is the first of n pull requests implementing this feature, where possible link to the task. And then I try to explain the further strategy at a high level, but let's start with this. And but other than that, I don't have any particular mental model or something organized. It's more like, as I said, creative. You have to take a look at the stuff. Speaking about your comment, it's a very good comment, and this is something that I would actually advise to people. Like when you wanna consider how to separate interface from the core, think that you're having like a second interface. We also had these situations at the previous company I used to work for. We had to support like the regular REST together with PostgreSQL interface. So we pretended to be a PostgreSQL database, and so that was quite interesting. And this revealed quite a lot, And so just imagine that you're dealing with a second interface, and this kind of helps clarifying what is actually the role of the interface versus what is the role of the core. So for example, if you deal with REST and GraphQL, GraphQL does normalization itself. So you define the schema, and then you will have Absinthe doing this normalization stuff, right? So that's like a very good comment. Thank you.
Thanks.
Hi, thanks for the talk. Can you go back to the slide where you test registration with a already used email? I think
a second. I cannot currently, or is
okay.
Where is this?
Okay, so let me in the meantime talk.
Can you maybe
and ask the question. So we try to follow that kind of similar approach to testing to make the test more clear. Now imagine in the application that the next one.
That one.
Yeah, perfect. So imagine that in this system, the user can then like create a post, and then they can even comment on their own post, and then they can like some other person's post and whatnot. Meaning like this, the model is kind of pretty complex, right? So, and also you want to test like a behavior that says the user can unlike some other person's post, right? So to make the test more clear, the approach that we're taking is like we would say at the top of the test, like, hey, give me a comment, right? And what would be your suggestion for a situation where the model is complex? Would you have like a explicit setup where you would say like register the user, create a comment, post, and whatnot?
I would do exactly what you would do, right? Because now these low-level operations sort of become your assembly for the stuff you want. You should always clarify what it is that you want, but definitely not like do this, then do that, then do that, then do that, and then like it goes on and on and on, and you have like 20, 30 lines of code before you actually have set up your like the what is it called, the arrange phase in the AAA pattern, right? So I would do precisely what you said.
Okay,
right?
cool. And would you did you consider like a more like a declarative approach versus this imperative? Like you would say like, I want to have like a comment instead of like create a comment. Do you think there's like any difference there?
Yeah, the thing is like, how would you describe it in plain English to another person, you know? Would you go all about these steps, or would you just say, you know, I need this kind of comment and then I want to check something with that prerequisite in mind? And if that's the answer, then this is how I would do it, right? Okay. If that answers the question.
Yeah, thanks.
I guess I'll ask the last question. Thanks for the talk, Saša. I also have a question about testing. I think the idea about testing. I think the idea of testing the use case is really interesting. I think in the example of the user test, a lot of the tests will actually try to query a database and see if the user is actually created. And do you have confidence in the test when you don't actually test that? Would you say that maybe there's still a success response, but the user is not actually created?
Okay, thank you. Thank you for asking it, because I was thinking about that in the discussion about that, you know, in the actual presentation. So just to clarify, the question is like, you know, I have this test. Actually, now maybe I can still move here. We have this test, right? And so I'm not actually checking that something is stored in the database. It's kind of implicitly checked, right? So this test could easily be defeated. So for example, if, I don't know, process dictionary is used, right? Or ETS table, you know, and so the test would be passing, but we're actually not storing something into the database. But I'm not in the business of defeating tests, so there's that. Otherwise, you know, other practices such as code reviews should be able to establish that. And then finally, you know, this is not the only testing you should do. You have like end-to-end tests, various other quality assurance tests, which should, you know, basically verify those kind of things. But I would not bother about actually checking that something is stored in the database.
Right. So if there's an integration test, it should definitely find the user in the database, because there's a higher level integration test that would actually do the check.
Some sort of an acceptance test, you know, which is done on the real thing, on the deployed thing, should actually find. But again, I would not directly check it, like have a query, database query inside any sort of test, if you will, you know, because this is an implementation detail to me.
Sure, thank you.
Hi, thanks. Oh, sorry. Thanks for the talk. I wonder if you have some sort of strategies or patterns on how to introduce the clarity concepts that you have showed us to your development team.
I'm sorry, on how to?
On how to introduce and encourage the development team to use the concepts of clarity, etc.
Well, you may want to start with some high-level presentation, you know, such as this, probably, you know, delivered over like a double amount of time, and just, you know, explain this idea. And you need, everyone on the team should agree, right? So this is one important thing, you know, like if we cannot reach consensus of roughly what we want from our code, you know, then we're going to be a pretty bad team, you know. So we have to find some common ground, like what kind of things we want. And so you can do some high-level discussion about it, maybe with some examples, so everyone is on team. And what you want to go from there is, I would start with code reviews. This is to me the key practice that, you know, everything comes out of that. I've seen so many rants about code reviews, but I think that people are maybe, you know, I don't know what are the reasons actually, but what I can say from my experience, I've been doing them for the past 7 years at work, you know, everything was reviewed, and it's one of my favorite practices, had predominantly great experiences. So if you do like these collaborative style reviews where everyone tries to work with each other, this is the practice which enables everything else. And so from there you're going to see organic problems rather than discussing some abstracts, right? So you're actually going to see the problems you're dealing with, and then you're going to try to see, okay, how could we clarify this? And the author and the reviewer may want to work together. Obviously, of course, pair, especially initially, because you know, this process is going to initially be a little bit bumpy until it clicks in. But what I can say from my experience, I don't have any hard measures or anything, but I think that you're not even slower because of that, you know, because when you have like a good organized pull requests, typical review will take like 10 to 15 minutes of time. There will be, of course, some exceptions when something is more involved, but most of the time, you know, it's just, you're just reading it almost like a book, you know, next. Oh, I have like this small remark, but it mostly looks good to me, you know, and so it doesn't really take up much of the time. And then it becomes really, it's worth paying off, because it starts paying off because people revisit this code and they are way more confident about working with it. They spend way less time fighting with the code, you know. So, but you know, I would start with code review, maybe some, you know, automated checks, as I mentioned earlier, you know, formatter, the linter, some, you know, Credo, style guide, and then go from there to see, you know, where it takes me.
Okay, thanks very much.
All right, so we got time for just you three, and we're pushing the time list. All right.
Hello. So first of all, it's very exciting to see you in person. I usually watch you on YouTube, so it's cool. I have a question about the second system effect. Okay. So you mentioned that it's like very common to have that. So how would you suggest to avoid like most of the mistakes or main mistakes in that sense? So let's say I know the company who already went this way, like second system, and yeah. I just would like to know how to avoid the mistakes, let's say.
Well, I guess the most obvious way to avoid the second system effect is if you don't write it, right?
It's too late already.
Well, I don't know. I mean, you know, I understand the impulse to rewrite everything. You know, I've been developing professionally as a full-time professional for 20 years. You know, so and I worked on some, you know, pretty disturbed legacy code bases and produced, unfortunately, some of those myself. And I can understand the sentiment of, you know, now we're going to rewrite it and now we're going to do better. And there are certainly, probably there are, you know, situations where really it's like to the point where the original stuff doesn't really make sense at all. You know, I could maybe even name one or say that one from my past actually was like that. But most of the time, I feel why I mentioned that thing is that people are getting too eager to rewrite. You know, like, oh, this is getting a little bit confusing. Let's rewrite everything. You know, so that comment went really into the way of like, you know, don't go for rewrites, go for gradual refactors. You know. But what was it seems I didn't answer the questions.
Yeah, I mean, we already went to the way of second system, so I would like to know if there are like common pitfalls in there or something like well known, which we might not know.
Yeah, I cannot really make any comment that would have any foundation because I didn't rewrite anything so far. So
smart enough.
Yeah.
Okay, thank you.
Okay.
Hi, so I'd like to say that it's also super cool to see you in person, and I actually got interested in Elixir because of you, among the others, because of your presentation, The Soul of Erlang and Elixir.
Okay, thank you.
Super cool.
Happy to hear that.
Yeah, and my question was, you mentioned that you want to have tests, like when you are wondering what level of tests to select, like higher or lower, you want to make it like the same way you talk to someone. So you want to have the same level of description, and so have you got any experience like actually creating like domain-specific languages so they fit better for the problem? Like have you ever used and you've got any opinion of the like tool of extending the language that you are writing?
You mean like writing? Oh, you mean like writing DSLs for those tests? Mm-hmm. Yeah. I don't want to say publicly something, you know, that will come off as a wrong way. So I personally don't use that as much. You know, for me, when we talk about these tests, they are made for programmers. And, you know, why would I use any other language than the language I'm using for everything else? You know, it's the most expressive language, and with some lightweight abstractions such as this, you know, some function wrappers, you can get close to the domain-specific language. Actually, if I remember correctly, you know, it was a long time ago, Martin Fowler had an article about DSLs, and I think that he called those things internal DSLs, in the sense that you're just defining some abstractions inside the language rather than defining the entire language. You know, DSL would make sense if you want to involve non-programmers into that. This is something I mostly didn't do or don't have any experiences with it, so I don't want to make any comments about it.
So this is not a tool to use lightly?
For what would you use DSL other than non-programmers? Why would you want to invent DSL?
So for a problem that is Well, okay. This is I didn't have any particular problem.
Okay, I mean we can discuss it later, but
Yeah.
DSL is adds a lot of overhead itself. So I mean it's going to be weakly supported language compared to say Elixir, with less support in tooling and abstractions and whatnot, and you got to have good reasons to do this.
Yeah, makes sense. Thanks.
Okay.
You can find me later and after the talk.
You can ask later. So we're out of time. Thank you everyone for your questions. Let's give Saša one more big round of applause.
Thank you.